Now we're going to solve an absolute value inequality. There are 3 steps here. So step 1, isolate the absolute value expression if necessary. Step 2, rewrite the absolute value expression as a compound inequality. Step 3, solve each part of the compound inequality for x. So example 3, solving absolute value inequalities and then graph. So step 1, the absolute values are by themselves, so we need to go to step 2, rewrite the absolute value expression as a compound inequality. So we have, just like when we did our, when it was equal to, we write 2 equations. So 2x plus 1 is greater than or equal to 5. We also have 2x plus 1 is less than negative 5. So when you switch to be a negative, you have to switch the sign as well. So you need to solve both. So over here we need to minus 1 because it's the one that doesn't touch the x. So 2x is greater than 5 minus 1 is 4. Divide by 2. X is greater than 2. Over here, same thing. We have to minus 1. So 2x less than negative 5 minus 1, though, is negative 6. Still divided by 2. So x is less than negative 3. We need to graph these from negative 3 to 2. 2 has an open circle and points to the right. Negative 3 is an open circle and points to the left. B. We have to isolate the absolute value expression. That is necessary this time. So we need to minus our 16. So we've got absolute value of 4x is greater than negative 8. Now, we need to hold on a second. Anytime we have a negative number, we have the absolute value on one side and then a negative number on the other side. We need to stop. We have 2 solutions possible. It is either going to be all real solutions or no solutions. It is based upon which way does your sign face. If your sign is greater than, you are going to have all real solutions. So any number I plug in here is going to be greater than 8. Because if we do 4 times 0, that's 0. Absolute value of 0 is greater than negative 8. 4 times 2, if we plug 2 for x, 4 times 2 is 8. Absolute value of 8 is positive 8. 8 is greater than negative 8. Even if we plug a negative number, 4 times negative 3 is negative 12. But the absolute value of negative 12 is positive 12. 12 is greater than negative 8. So any number we choose to plug in for x, we would get all real numbers because any number will work for this. C. Once again, we have to get the absolute value by itself. So that 2 is being divided by, so opposite of divide is multiply. And that cancels over there and multiply by 2 over here. So we have the absolute value of 3x minus 9 is less than or equal to 12 times 2 is 24. We're at a positive number here, so we're okay to keep going. Write your 2 equations. So 3x minus 9 is less than or equal to 24. And we also have 3x minus 9, flip our sign, negative 24. We need to solve both now. So plus 9, so 3x less than or equal to, we have 33, divide by 3, x is less than or equal to 11. Over here, add our 9 again. 3x is greater than or equal to negative 15. Divide by 3 because that's what touches x. So x is greater than or equal to negative 5. We need to graph now. So all the way from 5, negative 5, to 11. So count by whatever you would like to count by here. I'm counting by 2's. So negative 5 was a closed circle and points to the right, and a negative or a positive 11 was a closed circle and points to the left. So we are shading between the two. And our number line had little arrows at the end. So D. Once again, get absolute value by itself. So we've got a negative 4 that's being multiplied by that. So divide by negative 4. So absolute value of x plus 3. We divided by a negative number, so the sign needs to flip. Negative 2. Hold on. We talked about negative numbers. We can't have negative numbers over here. So when the sign was pointing the other way, we had all real numbers. When the sign points this way, we have no solution. There is no number we can plug in for x that will give us less than negative 2. We can't even get to negative 2 to be equal to. Try E and F.